Hey, science enthusiasts, ever found yourself puzzled by the mind-bending world of quantum physics? Look no further. In today's video, we're taking a whirlwind tour through over a century of quantum discoveries, theories, and key players. From Max Planck's pioneering experiment in 1900 that kicked off the quantum era, to the cutting-edge quantum technologies of today, we've got it all covered. Get ready to expand your mind and question the fabric of reality itself. Planck's constant was introduced by Max Planck in 1900 and has the value 6.626070015 times 10 to the power of minus 34 square meter kg/s. The photoelectric effect explanation won Albert Einstein the Nobel Prize in Physics in 1921. Louis de Broglie proposed wave-particle duality in 1924, suggesting particles could exhibit both wave and particle characteristics. The Schrödinger equation came from Erwin Schrödinger in 1926 to describe wave function evolution. Werner Heisenberg formulated the Heisenberg uncertainty principle in 1927, stating you cannot measure a particle's position and momentum precisely at the same time. Pauli exclusion principle was articulated by Wolfgang Pauli in 1925, noting no two identical fermions can be in the same quantum state. Niels Bohr presented the Bohr model of the hydrogen atom in 1913. The Copenhagen interpretation was proposed around 1927 by Niels Bohr and Werner Heisenberg. Quantum entanglement was explored in a 1935 paper by Einstein, Podolsky, and Rosen, presenting the EPR paradox. John Bell proposed Bell's theorem in 1964, arguing quantum mechanics predictions are incompatible with locality. The many worlds interpretation was introduced by Hugh Everett in 1957. David Deutsch and Richard Yoser demonstrated the advantages of quantum computing in a 1992 algorithm. Friedrich Hund first explained quantum tunneling in 1929. Quantum dots were introduced in 1980 for uses like LED displays and biological imaging. Superposition states particles can exist in multiple states simultaneously. Charles H. Bennett and Gilles Bressard proposed quantum cryptography in 1984. Quantum field theory emerged in the late 1920s. Quantum chromodynamics was developed in the early 1970s. Quantum harmonic oscillator provides a basis for understanding various physical systems. Feynman diagrams were developed by Richard Feynman in 1948 to represent mathematical expressions for subatomic particles. Wolfgang Pauli first introduced spin in 1924 as a form of angular momentum for elementary particles. Quantum teleportation was first achieved in 1997. The no-cloning theorem was proven in 1982. Hawking radiation was proposed by Stephen Hawking in 1974. Decoherence was proposed in the 1970s to describe quantum systems transitioning to classical behavior. John Archibald Wheeler conceived delayed choice experiments in 1978. The Aharonov-Bohm effect was predicted in 1959. The quantum Zeno effect was proposed in 1977. Pilot wave theory was proposed by Louis de Broglie in 1927 and extended by David Bohm in 1952. The quantum Hall effect was discovered in 1980. Shor's algorithm for factoring large numbers was proposed by Peter Shor in 1994. Eugene Wigner proposed Wigner's friend in 1961. Quantum dots for qubits was proposed in 1998. Quantum sensors developed in the 21st century use quantum coherence for sensitive measurements. Quarks were proposed by Murray Gell-Mann and George Zweig in 1964. The Higgs boson was proposed in 1964 and confirmed in 2012. Virtual particles emerged due to vacuum energy fluctuations. The fractional quantum Hall effect was observed in 1982. Topological quantum computing was proposed in the early 2000s. The quantum cascade laser was invented in 1994. Peter Shaw proposed the first quantum error correction codes in 1995. The Bose-Einstein condensate was first created in 1995, after being predicted by Bose and Einstein in 1924-25. The Jaynes-Cummings model was proposed in 1963. Quantum optomechanics is an emerging 21st century field. SQUID was invented in 1964 and is sensitive to magnetic fields. Quantum imaging was first demonstrated in the early 2000s. Yakia Aharonov proposed weak measurements in 1988. Berry's phase was discovered in 1984. Adiabatic quantum computing was introduced in 2000. Google claimed to achieve quantum supremacy in 2019. Max Planck conducted the first quantum physics experiment in 1900, discovering energy emission from hot objects in discrete packets. Albert Einstein proposed the photoelectric effect in 1905 and won the Nobel Prize for it in 1921. Niels Bohr proposed an atomic model with discrete energy levels in 1913. Werner Heisenberg's uncertainty principle emerged in 1925, stating the impossibility of knowing both position and momentum of a particle simultaneously. Erwin Schrödinger's wave equation appeared in 1926. Paul Dirac developed a quantum theory of the electron in 1927, predicting antimatter. Wolfgang Pauli's exclusion principle appeared in 1930, fundamental to atomic structure. Einstein, Podolsky, and Rosen questioned quantum entanglement in a 1935 paper. Hugh Everett's many worlds interpretation surfaced in 1960. Alain Aspect confirmed quantum entanglement in 1982. David Deutsch suggested quantum computing in 1989. Andrew Steen's fault-tolerant quantum error correction code was proposed in 1998. Shaw's algorithm for factoring was developed in 2001. IBM built the first quantum computer to factor a large number in 2012. Google's Sycamore outperformed classical computers for a specific task in 2016. Quantum computers in 2023 are in early development stages but promise to revolutionize multiple fields. From Max Planck's initial experiment in 1900, which introduced the world to quantum physics, to the emerging technologies and concepts of the 21st century, this list spans over a century of intellectual endeavor. The potential applications of these quantum concepts are boundless, promising to revolutionize fields ranging from medicine and materials science to finance. The journey through quantum mechanics is far from complete, but what has been explored so far serves as a testament to human ingenuity and the pursuit of understanding the deepest laws of nature.